So we're going to look at proving the converse of the Pythagorean theorem, which states that if you have a triangle such that the length of the smallest side squared, we'll call it b in this case, plus the length of the middle side squared equals the length of the longest side squared, then that triangle is a right triangle with the right angle being opposite the largest side in the triangle, so opposite side C, showing that right angle occurs at angle C. So that's our setup. All right, our strategy here is we have our original triangle with sides of length A, B, and C such that a squared plus b squared equals c squared. What we're going to do is go to our xy axis and on those create a side of length B and a side of length A and form a triangle. And we know that we're going to have a right triangle because we're creating those side lengths of A and B on the x and y axes as such. So since in our original triangle we're given a squared plus b squared equals c squared, on the triangle that we're creating on the xy axis here by the Pythagorean theorem, we know that a squared plus b squared equals x squared. And if we then look at those two equations together, we can see that x then must equal c. So then looking at this triangle that we created here, we know then that we have its hypotenuse equal to c. Take a look then at your two triangles, the one we started with and the one that we've created. They're going to be congruent by side, side, side triangle congruence postulate. And therefore, if those two triangles are congruent, corresponding angles in congruent triangles are congruent. So this angle down here is going to be congruent to angle C, making angle C a right angle, which was what we wanted to prove.